Hey everyone, welcome to Singularity Computers Client Build 5, Part 5, and this system is called Nighthawk. I'm going to start this video by doing the finishing touches to the water cooling loop. After that, I'm going to swap over the power supplies as I talked about at the end of Part 4. I'm then going to move on to the wiring, and there is a lot of wiring to do in this system. After that, it's just a matter of installing the lighting, and I can then move on to the filling of the water cooling loop. Okay, so this water cooling loop is almost complete, but as some of you might have noticed, there's something that I haven't done yet. I haven't yet installed a drainage system. Normally I use coolant quick disconnects, but in this system there's no room for them because they're too long. The only places that I could potentially put them is on the tube that goes between the GTX 560 and the GTS 240. But then you'd need to remove the GTS 240 to undo the quick disconnect. And I want a drainage system to be quick and easy. The only place other than that is on this tube here, which comes up from the GTS 240. But for one thing, there's too many bends in the tube, and again, you wouldn't actually be able to get your hands in there to undo the quick disconnect. So this is what I've come up with. It's a combination of coolants and bits power components, and I'm just going to give you a quick look around. The tap, as you can see, is made by bits power. It's actually a black sparkle component. It has female G1 1/4" threads on both ends. Just to look at the top, another bits power logo up there. This fitting here is a dual male fitting. It's another bits power black sparkle fitting, and then I have a bits power rotary fitting here, and this part of it is made by coolants. Now this is a versatile little component because it has 5 openings, all G1 1/4" threads, 2 on the top, 1 underneath, and 1 on each end. So it can be used in a bunch of different configurations. Okay, I've installed the drainage system, and I've also done a lot more work on the wiring. So you can see the coolants component here, bits power rotary fitting there. I've swapped this fitting to a 90-degree single rotary, 90-degree dual rotary here, and that tube goes up to the top compartment, and the bits power tap. So it almost comes out to the edge of the case, which is perfect. That's going to be just about touching the inside of the side panel, and it's going to make this system so incredibly easy to drain. All you need to do is remove a stop fitting from the top of the reservoir, install a barb fitting onto the tap, push a piece of tubing onto the barb fitting, and open the tap, and that will drain almost the entire loop, because this is just about at the lowest point. Installing a drainage system into your water cooling loop is certainly not mandatory, but I definitely recommend it. When you're building your loop, you need to think about how you're going to drain it and how you're going to dismantle it when the time comes, because if you don't, it can be incredibly difficult to drain it. Okay, so I've removed the Silverstone Strider 1500 watt, but I've been unable to install the Corsair AX1200 because it hasn't actually arrived yet. Despite that, I've done almost all of the cable management, and I've pulled all of the cables through down here, ready for when the power supply arrives. Now, some of you are no doubt going to find this difficult to believe, but so far I've spent over 6 hours on the wiring in this system, and there's still about an hour left to go. The reason that it's taken this long is most cases have plenty of dedicated space for wiring behind the motherboard tray, which makes things easy. But this case has no space behind the motherboard tray whatsoever. All of the excess wiring needs to go into the bottom compartment. But thanks to my radiator configuration, there is very little space in the bottom compartment for wiring. And as you might be able to imagine, if I have too much wiring down there, it's going to block the airflow from the 560mm radiator. So I've been doing my best to hide as much of the excess wiring as I can elsewhere. Now the wiring that I'm using in this system is a Corsair individually sleeved black cable kit for the AX1200, and I've also used a number of Bitfinex Alchemy Black extension cables. So I'm just going to take you around quickly and show you what I've done. I'll give you a good look at everything later on. So you can see I've connected up the graphics cards. I've also connected up the 24-pin motherboard power and the two 3-pin connectors from each of the pumps. So that's to read off the pump RPMs. So the 24-pin motherboard power and all of the wiring from the graphics cards goes down through this hole next to that tube just there. So actually the wiring from the 24-pin motherboard power only just fit there, because the 6990s come right down and almost touch the 180mm fans. There's only about a 10mm gap there. So thanks to the fact that I'm using individually sleeved cables, I was able to spread out all the individual wires and get it down through that hole there. I've also connected up the 8-pin and 4-pin CPU power and all of the front panel connectors. I did have the front panel audio connected up, but I just have it out the back of the build there at the moment because I'm putting some heat shrink onto it to cover up the multicolored wires. I'm going to do the same to this USB wire here. Now, the bulk of the time doing the wiring was certainly not spent wiring up the motherboard. That only took about 10 minutes. Most of the time I spent on the wires that go to the front of the build. I've connected up both of these, the SATA data and SATA power, and you can see through there, there's a bundle of wires. Now that's all tied together really tightly because there's between 20 and 30 wires just there. And putting those up one at a time took a long time. I've bundled a lot of the front panel wiring, the excess had to all go up in the top here above the optical drive. So yeah, that's where all the time was spent. I also have an LED strip installed. I've installed it up into the top here. It's a Bitfinex Alchemy white 30cm LED strip. Perfect little gap for an LED strip just there. And the wiring goes out through that gap just there above the optical drive. And I might also be installing another 12cm LED strip in behind the res just there. The lighting at this point is not confirmed though. Originally I was planning on using a Phobia RGB LED strip remote controlled lighting system. I actually have a review on this lighting system on my channel. I'll put a link on the screen. The reason I didn't use it is because it would have created too much cable bulk. It just didn't suit this system, in which it's really hard to deal with cables. I wanted to keep everything as clean as I possibly could. But anyway, at this point in time, I'm either going to stick with white lighting all round, or I might go with a combination of white lighting and UV lighting. I still need to install the LEDs in the memory water blocks and also the CPU water block. So that's the maximum amount of lighting I'm going to have, just those LEDs and the LED strips. Whether it's going to be white or UV, I still have to decide. I'm just going to see what looks good once I boot the system for the first time, you know, and there's coolant in the loop. Now, something that you have to think about with lighting is that it's purely for aesthetics. So basically you need to design your lighting so that it makes your system look as good as possible. And the way to do this, I mean, everyone has different opinions. My opinion is that you need contrast from light to dark, because without light there's no darkness, and vice versa. You know, everything has its polar opposite, and it's nice to show the polarities of light and dark in a system. In my opinion, that is the way to create the best aesthetic. Okay, so another little change that I've made. I've removed the temperature sensor from here. And this is because somebody reminded me that in Singularity Beast 2, I'll put a link on the screen to that build log. When I installed a temperature sensor in this same pump top, it actually blocked the flow of the water cooling loop. Not completely, but it really slowed it down a lot. I actually had it installed in the top last time, so I thought that this might be okay, because what I actually did when I installed the temperature sensor, I looked down from the top and the temperature sensor was not blocking the flow of the loop. But weirdly, somehow it still manages to block the loop. So anyway, I just decided not to take the risk because of the problems that I had in Singularity Beast 2, and I removed it. So the water cooling loop has no temperature sensor, but that is not what's important. What is actually important, obviously, is the temperatures of the components. The temperature of the coolant and, you know, the ambient temperature, all of that doesn't matter so much unless you're really fussy about monitoring. So the water cooling loop is complete and ready to fill. Now it's time for me to install the power supply, finish the wiring, and also finish the lighting. Okay, I've skipped a few big steps here, and I'm now going to go back and explain them. So I've installed the Corsair AX1200. I have almost completely finished the wiring. I've finished the lighting, and other than that, everything else is completely finished. What I've started to do here now is prepare to fill the water cooling loop. So I have all of the coolant and the distilled water ready to go, and I'm now going to talk about what you need to do when filling a water cooling loop. So you need to take every precaution that you possibly can, because it doesn't matter how good you are at building a water cooling system. It doesn't matter how much you've taken your time with everything and got everything as perfect as possible. There can still be faulty components. You could have a radiator leak, you could have a water block leak. You never know if there was a little tiny split in an O-ring or something caught in an O-ring somewhere. So you have to prepare for the worst. What you need to do is leak test your system. Now you do this before you boot the system, before you power on the system. This means that you need to power the pumps separately somehow from the system so that you can power the pumps on their own without powering up the rest of the system. Now there's a number of ways of doing this. You can get an external power supply for your pumps of some kind, but the easiest way to do it is actually to get an external power supply, just like this, an old one, a spare one that you have, and connect that up to your pumps. So you can see power supply here, I've got the two pumps connected up. Now what you need to do to start your power supply outside of your system is get something like this. So this is a 24-pin motherboard power connector, and it has the two pins shorted that are the same two pins that the power button on your case shorts. This is the one that I'm using today, so it's basically just the exact same thing as this. It has those two pins shorted, except it has a switch, so I'm able to switch the power supply on and off, which is great because you do need to be able to switch the pumps on and off, because basically you'll see what I mean shortly, but you can't just turn the pumps on and leave it running the first time you fill your loop. You can see the AX1200 in there, and I'm not going to talk about too much of this now. I'm going to go over it all later, because I'm better off showing you the build once the coolant is in it and it's all finished off, because then I can go around and show you absolutely everything. Now it's time for me to mix up the coolant and fill the loop. Now, as I've mentioned previously, the coolant that I'm using in this system is Mayhems Pastel Ice White. And you can also see there that I have some dye. This is UV dye. I'm not sure if I'm going to be adding this yet. I'm going to see how the Pastel Ice White looks first in the loop. And yeah, I might add some UV later. So I have here the Coolant Concentrates. They're 250 mils. And with the pastel coolant, a 250 ml concentrate makes 1 litre. Behind the coolant there I have a mixing bottle with measurements on it, and on the left hand side I have some distilled or deionized water. So that is what the coolant concentrates need to be mixed with. Now you can do things the easy way, and Mayhem sells pre-mixed coolants which you can just put straight into your loop. But if you get the coolant concentrates, I am just going to quickly show you how to mix them. Okay, just quickly about the distilled water that I'm using. I'm not going to go into too much detail here. Basically you can get distilled water from your local store. It's easy to come by and it's cheap. But if you're fussy and you want something that's more pure, then Mayhem sell their ultra pure H2O. So this is just deionized distilled water that goes through a higher filtration process. So you can read about it on the website. I'll actually put a link to the Mayhem's website in the video description. So yeah, they basically put it through a whole bunch of different filters. It is as pure as it gets. What I have here is laboratory grade distilled water. So this is more pure than your average distilled water also. I actually got this from a local medical supplier. But yeah, I'm just using this because I'm fussy. The real world difference between your average distilled water and laboratory grade distilled water, yeah, I'm not sure how much of an effect it's actually going to have, because as soon as distilled water comes in contact with air, it's going to start taking on ions and becoming conductive, and it can then grow algae anyway. But don't worry, because the coolant has antimicrobials, it stops algae growth, it also has corrosion inhibitors. The coolant concentrates have everything that is needed in a water cooling loop to make it run perfectly for a long period of time. Okay, so here we go. Now a funnel would be good. I only have this little funnel laying around with a G1 1/4" thread on it, so that will have to do. And I'm just going to pour the entire thing in there, because this entire bottle makes 1 litre. So, and you can see 1 litre is up there. So now I'm just going to pour in the distilled water until it gets up to 1 litre. So don't drink the coolant. It is toxic, and they also say to dispose of it properly. Don't pour it down the sink. So that's it, the bottle is full. I'm now just going to give it a good mix, and it's now ready to put into the loop. So that is the simple process of mixing Mayhem's coolants. Now I will go into more detail and elaborate on what I've talked about today in my upcoming video on Mayhem's coolant. Okay, it's now time to fill the loop. So I'm going to start from back here, and when I actually turn on the pumps, I'll get some good close-ups so you can see what's going on. Okay, so as you can see, the res is full. It's almost taken that entire 1 litre of coolant to get to this point. But I'll just show you. So the entire res is full. You can see that the pumps are full, and the coolant has started to come back up here, which means that the GTS 240 and the GTX 560 in the bottom compartment are both full. They're not entirely full, they'll still have some massive airlocks in them, but you can also see that it's filled up the lower memory water block and started to climb up into the MOSFET water block. So I'd say probably about another litre and the loop should be just about full. So while you're filling the loop, you need to go around and continually check everything for leaks, because you're far better off catching a leak as early as possible than leaving it until after the entire loop is full, the coolant is circulating, the pumps are up and running. So yeah, catch it early, keep an eye on the loop. Now it's time for me to turn the pumps on. So I have the switch here to turn on the external power supply, but I'm just going to get you back on the tripod and then I'll flip the switch. Flicking the switch now. So a bit of a delay because there'll be a lot of air in the pumps. Okay, there must be a lot of air in there, so it's moving a little bit slowly. Okay, so I've just switched the pumps on and off a few times, so I'm cycling them just to get the air out. It is going a bit more slowly than I expected, and I think it's just because of the dual pump top. There must be an airlock in there somewhere that's a little bit difficult to get out. There seems to be a lot of air staying around the pumps. Normally, with a single pump, you'll just see it start up and start going through the loop incredibly fast. Check out the client build 4 build log and you'll see what I mean. Basically you flick the switch and the coolant is circulating within a couple of seconds. But yeah, I think it must be due to the dual pump top that it just takes that little bit longer to get the air out of the loop. There also is a hell of a lot of water blocks. I mean, I've got multiple radiators and all of that, so yeah, because of that it takes a little bit longer. So now I'm going to, I'll just put this syringe in and then it's time for me to mix up some more coolant. Okay, I'm just going to flick the switch again, get the rest of this coolant through. Okay, you can see it's starting to speed up now, so it's starting to get some of that air out and circulate. Okay, that's where you want to stop it. You don't want to let any air go through the pumps. Well, as little air as possible. As long as there's some fluid going through the pumps, you're not going to damage them. But if they run completely dry, you will damage your pump. So be careful of that. Okay, I'm just going to flip the switch again now and run the loop again for a little while, drain that res out. I might even be able to keep it running at this point in time if I can keep up with the pumps. So there we go, that's what I was talking about, where the airlock gets out of the pumps and it starts to really move quickly. So I'm able to keep up with the pumps now, which means I can leave it flowing. And now it's time for the leak test. It'll take a while for all of the air to come out of the loop. Okay, now it's time for a look around the system with the coolant in the loop. This is always an exciting step in a water-cooled build, and it's something that I've been really excited about with this build. I'm not going to give you a complete and detailed look around the system until it's finished. I mean, I still have to finish the wiring, and I also, once I've finished the system, I give it a complete clean. So just to remove any of the dust that's settled during the build, the finger marks, mainly the fittings, get a lot of finger marks on them. So I've topped up the res, and I also switched the pumps on and off a couple of times just to try to move some more of the air out of the loop. You can probably hear the pumps in the background. They're only noisy at this point in time because there's air in the loop. It's the air going through the pumps that causes the noise. Once that air is gone, the pumps will be silent. They're almost completely inaudible. Actually, once you boot the system, the fans are probably at least twice as loud as the pumps. So the pumps get drowned out and become completely inaudible once the system is up and running. You can see some lemonade in the res, the very small air bubbles. They take a long time to come out of the loop. And until all of the air is gone, it's not going to perform optimally. I mean, a small amount of air like that is not going to make a major difference, but that's a good thing. Another good thing about the 8-hour leak test that I do, by the time I boot the system, not only is the loop completely validated, all of the air is gone, so the loop is performing optimally, you know, how it should. So anyway, I'm just going to continue to give you a quick look around. So just to look at the graphics cards, the EK water blocks just look amazing in combination with the Mayhems coolant. I'm really happy with the color of the coolant. It's just how I wanted it, just how I imagined it. It's perfect. The color of Mayhems coolants is just amazing. I highly recommend that you click on the link in the video description and check out their website. They have the biggest range of coolant colors on the planet. They have some amazing coolant. Now for a look at the heart of the build. This is what I've been really excited about, seeing coolant in this part of the loop, to see how all of those water blocks look. So I'm really looking forward to getting the system up and running and seeing the loop with the lighting that I've installed into the system, because I think that's when it's going to look its best. I'll just give you a quick listen to the pumps. So you can't hear the pumps at all because the pumps kind of make a humming noise. What you can actually hear is the air just trickling through them. So you can see the coolant through the front of the pump top there. It looks amazing with the black pump top. Okay, it's now time for me to conclude this part of the build log. So I'm now going to leave the loop up and running for 8 hours for the leak testing and validation of the water cooling loop. After that, I will finish the wiring, and then I'm going to boot the system for the first time. So part 6 will be all about the overclocking and all of the test results, the performance results and temperature results. And I'll also be including the finishing shots of the system in part 6. So I'll give you a good look around the finished product and talk about anything that I haven't already mentioned. So the loop ended up taking about 1.5 litres. It was a fair bit less than I expected. With all of those radiators, yeah, I expected this loop to take a lot more. So there it is. I'm really happy with it. That sums up this video. Thanks for watching. Please subscribe, like and favourite if you want to see more.